Hello guys, I hope you all are doing very well. The video now is to talk about hypothesis testing. So there are a lot of different places in JMP that we can perform hypothesis testing. I recorded a video about this topic in Portuguese. The video was about half an hour. So thinking right now that video uh, should not be so long because I entered in a lot of different details, and here I will try to be more objective and show to you where we can find the hypothesis testing in JMP. So I have here a data table where we can see eight different response variables that we measured in 36 parts that came from different machines and different shifts and different days. So one of the first places that we can run hypothesis test is in the distribution platform. So in the other video you watched it, you saw how to use the distribution to talk about thinking about histograms, right? But we can perform some hypothesis testing here as well. So let's suppose that we can test the mean. We have a mean here about 99.015833, and we want to know if this mean is statistically different from a mean, for example, 90.0. So here in this red button we have the test mean. So we can choose test mean here, and you can put here your null hypothesis and just click on OK. You will have the first hypothesis test that you can find here. A simple one, a t-test, saying to you that this is statistically different. This is statistically bigger than the null hypothesis, the hypothesized value 99. If you had the standard deviation, the historical standard deviation, the true standard deviation, you could put here, let's suppose that you had 0.02, you will have a z-test instead of a t-test. So this is the t-test in the distribution platform. What more do we have here? So you can test standard deviation. For example, you can put here the 002, and you have the test standard deviation saying that your new standard deviation is bigger or smaller than the previous one. You can test the equivalence as well. So you put there 99, a difference that is considered practically zero could be here 1 micrometer. So you have this graph, this test equivalence, saying that your new values are far away from this target with the upper and lower equivalence region here. So you have a different value, and all the statistical details are here below. Okay, this is what you have inside of this distribution platform. Okay, let's go to the next place that we can perform this as well. In this graph builder, for example, I didn't record this in the Portuguese video. I forgot. I said at the end of the video that I knew some different places where we can perform the hypothesis test, but I didn't show to you. So if you are watching now, you are receiving a different information. So here inside of this graph builder, I have a video about graph builder that is very nice, talking about some functions here. One of them is, for example, the histogram. Let's put here, for example, y and different machines, and I will select histograms. So I have the distribution for the y1 for the machine number 2, and the machine number 2 and the machine number 1. I can run a t-test for mean here. So I can put here 99, for example, and I will have the hypothesis test here as well. Okay, so we have this even in the graph builder. Okay, the graph builder for me is a platform that has a different target, a different goal, right? Is to make some graphs. But if you want to show the hypothesis testing here, you can run this as well. And the last one, the last place that I would like to show you that where we can perform hypothesis testing is inside of this fit y by x platform. For me, is the most powerful one if you want to perform hypothesis testing. For example, let's pick different y's, the y number 1 and y number 3 here. So the 1 and the 3 for different shifts. Okay, so we have here two different situations. The moment that I choose a response variable that is a continuous value, and I'm analyzing this against a nominal value, a nominal column here, we have written here one-way analysis. Okay, one-way analysis, you already know that is a tool that we can compare things, and if we can compare things, we can run different hypothesis testing. So look what we have here inside of this little red button. You have means, ANOVA, pooled t, means and standard deviation tests, t-test, analysis of means method. You have 5 different tests here comparing the results. You can compare means, but how? Each pair students, all pairs Tukey, with best, with control Dunnets, each pair stepwise Newman Q's. You have non-parametric, another different hypothesis testing. Unequal variances, you wanna know if your variances are equal or unequal. You have here equivalence tests, mean and standard deviation, and robust. Okay, so I won't perform on every single one, because if I do this, our video here is gonna have like more than 30 minutes, so it's too long. You won't watch until the end. Okay, let's run some important tests here. Let's compare means, each pair students. So we have here two circles here. One circle is inside of the other one, so we have here the results that are saying that they are not so different. Let's run here for this y number 3 that we can already see that the shift 2 is very different from the shift 1. So let's use the same test to see the difference. Look that the circle representing the mean of this shift 2 is far away from the shift 1. So now we have some statistically significant values here. For example, the p-value here is 0.15 and here is less than 0.001. And every time that we have an hypothesis testing in JMP and the p-value is colorful, it means that you have a statistically significant result. If you put your little mouse here, you will have this message. The true value, the 3.71 exponential minus 18 is small enough to indicate very convincing significance. So this is one of the tests that you can perform here. Okay, guys? There is other tests, for example, means, ANOVA, bullet, T. You have here the RSquare saying that this difference is not something that can be explained by an equation. For example, one diamond is practically inside of the other diamond, so you don't have a difference that is statistically significant. Okay, let's run the same test here to see the difference. So now the diamonds are very different. You have some statistically significant results here. You have an R-square about 0.89. So this is another way, another tool that you have here. If you are comparing means, you want to use different tests, you have different tests here as well. And each test you run, you will have the name of the test here, all the comparisons made here below, and all the results as well. Okay, this is very powerful. I hope I could help you again, and that's it. I wish I could spend like hours here teaching you how to perform each one. If you would like to enter in more specific details about one of these tests, please let in the comments below and we can record a new video to talk about your necessities. Okay, guys, I really hope I could help you again. See you in the next one. Bye bye.